Sanjemi, back out here in Redington on our Redington project here. We're going to be talking about the structural details of the foundation here today. Dirk, if you can kind of take a look at the footers here, you're going to see that this project's been set up with quite a bit of steel. Actually, more steel than you'd ordinarily even see in a waterfront residence like this. And part of the reason for that is we've got a wall system that is a concrete wall system. It's a CMU wall system. That's a masonry wall system built in the garage level. And on top of that, an ICF wall system, which is 6 inches thick. And then on top of that, third floor is a 4-inch thick wall. So extra support's required to manage the gravity loads of all of that concrete. In addition to that, there's a concrete floor on the first floor. So that adds to the weight. So quite a bit of gravity here, resting from all of that concrete on these footers. So we're going to see 3 bars on the bottom, typically in a footer system like this. But we've actually got 4 bars if you look at this. And it's one of the details that you'll see with a good contractor like this is we'll take the pilings and we're going to go ahead and run rebar through all of the pilings tied in one continuous loop. And then our cage is going to go on top of that. So all of these stirrups are tied in a traditional fashion as drawn, but that additional support is in there as well. So that's nice. This foundation called for actually 4 bars, 2 tied in the center, 2 on the outside, number 5, and 2 on the top. And the top bars are designed to handle the uplift. The bottom bars are designed in a concrete foundation like this to handle the gravity loads. So you can see how that's a little bit unbalanced. There's twice as much steel in the bottom of this as there is in the top. The stirrups are designed to manage the shear. So shear would be pressure coming from wind. Those bars in the bottom of the footings are designed to handle the weight. That's really how this works. So this is all tied together in one continuous system. And as you see, all of these footers, they run in a grade beam fashion from the front of the property across the side of the property with all of the pilings tied together. Kind of looks like a war zone here because all the digging that's been done, but that'll all be filled in here once this foundation is completed. All of these uprights here are designed to be placed within the CMU block. So once this is poured, we're going to go ahead and we'll place the stem wall on top of that. That'll be a couple of courses, 2 courses of block, and these uprights will come through those areas. And as you can see here, there's extra uprights. If you pan around here, Derek, you'll see that in all the corners there are 3 bars. And the reason why we do this is 1 bar is required by code. The 2 additional bars are there for additional strength, so beefed up foundation. These, where you don't see bars, those are openings. So in the back here, you'll see this particular area is an open area. That is that's going to be open to the backyard. So that's going to be part of the lanai area. As we run through the foundation details here, you'll see all of the corners. Some of the things we want to look at. Thank you. Some of the things we want to look at is we want to make sure that our splices are overlapped properly. So this plan calls for a splice that has a 36-inch splice, and that's going to be a factor of the steel. It's going to the size of the steel. So a number 5 bar would have a different splice depending on the concrete strength as well. So all that goes into a formula, and that determines the splice length. Code's going to require this splice to be I think it's 31 inches. We added 6 inches because that's just the way we do things. We want to make sure that all the structural components are slightly overbuilt so that we never have any problems. In this kind of construction, this kind of green construction, a home like this, while it's more costly to build up front, will likely last 2, maybe 3 times as long as a home that's not built with these kind of details. So while we're going to spend maybe 20 or 30% more in the foundation details, this thing's built to last. It's also built to withstand the elements. With a foundation like this, we're never going to have to worry about this thing moving in a storm, right? If we have 150-mile-an-hour winds here, all of this needs to be tied into these foundational elements. And in order to make that happen, we've got to have continuous loads, uplift, and the gravity loads all tied to this foundation. So very important that this is well built.